Hello, Mrs. Finder here. So we're going to have our next lesson on probability now, and we're going to recap by looking at the probability line or the likelihood line that we learnt about yesterday. So remember, this line goes from 0 to 1. If an event is at the 0 end, that means it is impossible. Okay, there is no way at all that an event with probability 0 can happen. It's completely impossible. Okay, right up at the other end of the scale, we've got a probability of 1. And if something has a probability of 1, then it is guaranteed to happen. We say that it is certain. Okay, there is no way at all that that cannot happen. It's absolutely guaranteed. And then if we come somewhere in the middle here, where the probability is a half or 0.5, different ways of saying the same thing, then we call that evens. And what that means is it's as likely to happen as it is not to happen. Okay? And then if we just look at the other bits on our likelihood line, if something was in between impossible and evens, it would be unlikely. Okay? So the further it is towards this end, the more unlikely it is. So something down here would be very, very unlikely. Okay? If it was here on the number line, if it was just a bit less than a half, then it would be slightly unlikely. Slightly less likely to happen than not. Okay? Whereas if we go on this side, the further up we get towards 1, the more likely it is to happen. So if you're looking at around here, this is something that's almost certain. It's almost guaranteed, but not quite. There might be some little thing that can happen to stop that occurring. So further we get towards this end, the more likely it is. Okay? So for example, something around here would be quite likely to happen. Okay? So, quick reminder of how we calculate probability. So we do it as a fraction, and it's the number of favourable outcomes over the total number of possible outcomes. And I usually fill in the bottom of the fraction first because that's the easy bit to do. We can just work out how many different things can happen, and that number goes on the bottom, and on the top goes how many ways the thing in the question can happen. Okay, so we'll see what we mean as we go through these 3 examples. Okay, so first of all, we've got 15 socks in a drawer, 5 black ones, 3 red ones, and 7 green ones. If you take out a sock without looking, what is the probability that it is A, red? Well, let's have a look at that. So, remember the way we write it down is capital P, and then we write down what is in the question, the event that's in the question. So the event would be the sock is red if you pull it out at random. Okay, so the bottom of the fraction is the total number of possible outcomes. So that's the number of different things that can happen when you pull out a sock from that drawer. Okay, now because there are 15 socks in the drawer, there are 15 things that can happen. You could pull out any one of those 15 socks. Okay, and then the number of favourable outcomes that goes on the top, or in the numerator of the fraction, that's how many are red. How many ways can we pick out a red sock? Well, we've got 3 red socks. So there are 3 ways out of 15 of picking out a red sock from that drawer. So the probability is 3/15. Now, if you've done fractions before and you've done simplifying fractions, you will know that 3/15 is a fraction that will simplify. If you haven't done simplifying fractions before, don't worry about this. Leave it as 3/15. So 3 and 15 are both in the 3 times table. So we're going to divide top and bottom by 3. Okay, so how many 3's are in 3? There is 1. How many 3's are in 15? There are 5. So 3/15 is equal to 1/5. But you don't need to put that if you've not done simplifying fractions yet. Okay, next one. Probability that we pick out a black sock. Well, we set it up in the same way. There are 15 socks in the drawer, and there are 5 black socks. So there's 5 ways of picking a black sock, 15 ways of picking a sock, And this fraction will also simplify both in the 5 times table. So divide top and bottom by 5, you get 1 and 3, so it's 1/3. So 5/15 is equal to 1/3, and that's the probability of picking out a black sock, because 1/3 of the socks in the drawer are black. Okay, next one. Probability of getting a green sock. Well, there are still 15 socks in the drawer, and if we pick one out at random, there are 7 different ways of picking a green sock. Okay, so the answer to that one is 7/15, and that doesn't simplify because 7 and 15 are not divisible, they're not multiples of anything except for 1. Okay, and then last one, D, probability of getting a blue sock. Well, there are still 15 socks in the drawer. There are no blue ones. So the probability of picking a blue one out is none out of 15, which is just 0. And remember, that's impossible. We can't pick a blue sock out of a drawer if there are no blue socks in the drawer. Okay? Right, moving on to the next question. I select a playing card at random from a standard deck of cards. Find the probability that it is one of these things. Okay? So a standard deck of cards, just so you know, is we have all these different cards in each of these 4 suits. So we've got diamonds, hearts, spades and clubs, and in each of those we've got everything starting with an ace, which is 1, 2, 3, 4 and so on right up to 10, and then we've got jack, queen, king. So each suit has 13 cards in it, and there are 4 suits. Okay, so let's get started then. The probability of getting an ace. Let's have a look at that. So the first thing we need to work out really is how many cards are in this complete deck. Okay, now there are 13 different cards in each of the 4 suits. 13 times 4 is 52. So there are 52 cards in a standard deck of playing cards. Okay, and the aces, there are 4 aces in the pack. There's the ace of diamonds, the ace of hearts, ace of spades and ace of clubs. So there are 4 of those. Okay, so the probability of picking an ace out, if you just pick a card at random from a normal pack, is 4 over 52. That will simplify. They're both in a 4 times table and gives us 1/13. I'm not going to spend too long dwelling on the simplifying here because really this lesson's about probability, but if you've done simplifying, it's a good chance for you to practice it. Right, next, a black card. There are sometimes shortcuts to working out probability, okay? If we know something, extra information about the pack of cards, then we can jump to the answer quicker, all right? But let's do it the long way and then we'll show you how you could have done it quicker. So probability of getting a black card. There are still 52 cards in the pack, and the black cards are the spades and the clubs, and there are 13 of each of those, which makes 26 altogether. Now that fraction will simplify to a half, okay? We could have gone straight to that answer for probability because a half of the pack of cards are black cards, okay? So we can go straight there if we can spot a shortcut, but we need to be careful about doing that, okay? Oops. Part C, a probability of getting a picture card. So the picture cards are the jack, the queen and the king in each suit. So there's 3 of them, jack, queen, king in each suit. There's 4 suits, that makes 12. We know there's 52 cards in the pack altogether. Again, this one will simplify to give us 3 out of 13. Okay, and that makes sense as well because for each suit, 3 of the 13 cards are picture cards. Okay, right. D, probability of getting the 4 of diamonds. I'm not going to write out diamonds, I'm just going to put a picture there. Right, there are 52 cards in the pack. 52 different things can happen when you pick a card at random. Only one of them is the 4 of diamonds. Okay, so you've got as much chance of picking the 4 of diamonds as you have of picking the Queen of Hearts or the 7 of Clubs, or any one individual card has the same probability of being selected at random, and it's 1 out of 52. Okay, and then the last one, probability of getting a spade. Well, again, 52 cards. Spades are one of the suits, it's this one. And so there are 13 cards in that suit. 13 and 52 are both in the 13 times table. So it simplifies to 1/4, which makes sense anyway, because 1/4 of the cards in the pack are spades, because there's 4 suits. Okay? Right. Last question we're looking at today. Select a letter at random from the following. Aurora Eccles School. What is the probability that you pick a vowel, a consonant, an L, a C, or a K? Well, let's have a look then. So, first of all, probability of getting a vowel. If you pick a letter at random out of Aurora Eccles School. Well, first of all, we need to know what vowels are. So the vowels are A, E, I, O, and U. So let's count all those. So we've got that's a vowel, that is, and that is. Then the E's are, and then you've got 2 O's there as well. Okay, so the number of letters altogether in Aurora Eccles School, if we count them, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's going to be out of 18. And counting the vowels, we've got 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 of the 18 letters are vowels. So the probability of picking out a vowel at random is 8 out of 18, which we can divide by 2 and get 4/9. Okay, next one. A consonant. Probability of getting a consonant. We've still got 18 letters there. And do we need to count how many consonants we've got? Because consonants are all the letters that aren't vowels. So if we know that 8 of the letters are vowels, then the rest must be consonants. So there should be 10. So let's just count that. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's right, there are 10 18ths is our probability of getting a consonant. And again, that will simplify by dividing top and bottom by 2, and it will give us 5/9. It's worth pointing out at this stage that 8 18ths and 10 18ths make 18 18ths, which is the whole one. It's the whole lot of letters. And that 4/9 and 5/9 make 9/9, which is also the whole lot of letters. Okay? Right, part C. This time, probability of getting an L. Well, let's have a look, see how many are L's. Right, so as we go through, we've got 1 there, and there's 1 at the end of school. So there's 2 L's. So, again, dividing top and bottom by 2 to simplify gives us 1/9. Okay, and then D, probability of getting a C. Let's see, where are the C's? So there's 1 there, 1 there, and don't forget the 1 in school as well. So there's 3. 3 and 18 are both in a 3 times table, so we can divide top and bottom by 3 to get 1/6. And then E, probability of getting a K. Now, I haven't left myself much room here because I don't need it. There are no Ks in Aurora Eccles School, okay? So we don't even need to write down the fraction for this one. We can just say that the probability of selecting a K from those letters is 0 because there isn't one. You can't pick a K from those. Okay, so well done if you've kept up with all that, and you can have a go at the questions now. See you soon.